This is presentation for WP3 Scenario 1 IFIC analysis. In this presentation, we're going to show how we import SRS, IFIC, and GIMS databases into ICS Manager. Those data, we have already downloaded the IFIC database from the ITU site, and we're going to show how to import that into the ICS Manager. So we connect into the, we pick up that access database for IFIC to 857. And we're going to create a query to show the geostation satellites. So they are not all the geostation satellites in the IFIC. These are just the ones that are of interest for this scenario. So this is for example, this story is for the Ukraine, and they are imported here all the geostation satellites that are of interest to Ukraine. So we're going to pick up a few satellites in the analysis. And basically, we will be importing those satellites into the ICS Manager database. So here we are viewing basically what was in the IFIC database, and now we just imported 4 into it. And you can see the extract GXT contours. These come from the GIMS database. So basically, GIMS database sits at the background, and it basically, and the ICS Manager calls that database while processing data. Now, we have 7 satellites here, 3 for Ukraine and 4 for other countries. Now, we're going to group those into Ukraine and non-Ukraine ones. So basically, Ukrainians are the ones that are of interest to us. We want to look at the, analyze these satellites, to see what's happening with these ones, and we create another query that basically will only contain the other will be potential interferers for us. Now, when you create a query, you can set the fields that you want to see in the query. So we just added basically no defined country and satellite names to the query. Now you can go through each of these satellites and then look at the parameters. So basically, they have the emission for emission, gain contours. Obviously, these are coming from the GIMS database, these contour related data, and so forth. Now we're going to go through a process, and basically here into the performance, the interference analysis, we are going to basically give each one of these satellites status of potential interferer. So to do that, we're creating a new state, PI, for potential interferer, and then we create corresponding transition. So this has been covered previously in the workflow, so we might as well fast forward this bit here. Going to the transition. So now we're going to set the state to potential interferer for each for the first one, and we can show that state by adding that a new field into our query, and you can see the PI has come up now. So we do the same with the other 3 as well. So basically, we set them to potential interferers. Next, we're going to talk about IFIC analysis, which is interference analysis. There are two methods supported in the tool, C2I and threshold degradation, or which is delta T over T, interference analysis. So we're going to start with the Ukrainian satellite, which is our wanted stations, and we're going to identify which are the which stations are the ones that are interferers. So you can set up basically we can show the state of each satellite. So we are going to basically only select the ones that are PI, potential interferers. So the potential interferers, and the same with the other two satellites. So I'm just going to fast forward this. There are two ways of selecting, either doing through queries, or you can just simply, as shown here, just highlight those. So basically, as you can see, you can just highlight those ones and the satellites of interest, and that becomes your interferers. And then once they are basically selected, then we can do the we can basically go and look at the delta T over T view, which basically contains the calculation of the threshold degradation. And so here you can see that it comes up with the results. So we'll go through some of the record and see what they mean. So as you can see, here basically we have the interferer and the victim. So this is our interfering satellite, and this is the victim satellite, and it has the uplink and the downlink details for this analysis. It has results, which is will show you so higher than 6% is H and lower than 6% is L. Again, different parameters they use in the analysis. So this is it's a fairly low error. I mean,